We thought we understood the moon, a dead world, silent, frozen in time. We walked on it, brought pieces of it back, measured it, mapped it, named its scars. And still, it doesn't make sense. The moon should not be geologically alive. It should not hold water in the darkness. And it should not exist in the way it does. Yet it does. Somewhere in those craters, the answers are waiting. And for the first time in 50 years, we're going back to find them. For all its familiarity, the moon remains one of the most mysterious objects in our sky. 12 astronauts have walked on its surface. Hundreds of kilograms of rock have been studied in laboratories on Earth. But those samples came from just a handful of places, on one side of the moon. What we have is not the full picture. It's a fragment. And now NASA's Artemis program aims to complete that picture. The leading theory begins with a catastrophe. Over 4 billion years ago, a Mars-sized world collided with the young Earth. The impact was so violent that it blasted debris into orbit, which slowly came together to form the moon. It's a dramatic idea, and much of the evidence supports it. But there's a problem. The moon is uneven. The side we see from Earth is covered in vast, dark plains of ancient lava. The far side is completely different, thicker, rougher, almost untouched by those flows. Why would a single event create two completely different worlds on the same body? To answer that, scientists need samples from places we've never explored. Deeper layers, different regions. That's exactly where Artemis is going. Not just to visit the moon, but to read its history properly. For decades, we believed the moon was bone dry. Then we found water, hidden in craters near the poles, trapped in permanent darkness where sunlight has not touched for billions of years. Billions of tons of ice, preserved like a time capsule. But where did it come from? Comets, rich in ice, may have delivered it. Or asteroids, carrying traces of water locked in minerals. The answer matters more than you might think. Because the moon and Earth share the same origin. If we can trace the source of lunar water, we may uncover the origin of Earth's oceans. Artemis missions will land near these polar regions, where this ice exists. For the first time, we'll study it up close, not just as a resource, but as a clue to our own beginnings. By everything we understand about planets, the moon should be dead. It's too small to hold heat for billions of years. Its core should have cooled and hardened long ago. Its surface should be nothing more than a frozen record of the past. And yet, it hasn't. Deep beneath its surface, something still moves. Moonquakes ripple through its crust. Not once in a distant past, but even today. Some regions show signs of volcanic activity that, in cosmic terms, happened just yesterday. So the question is not just what is happening, it's why hasn't it stopped? There are only a few ways a world can stay alive like this. Leftover heat from its formation, energy released from radioactive elements, or the constant pull of a nearby planet stretching and heating it from within. But here's the problem. The moon doesn't seem to have enough of any of them. It's too small to hold that much heat, too poor in radioactive material. And Earth's gravity shouldn't be strong enough to keep its interior active. By every model we've built, this shouldn't be possible. So either something deep inside the moon is still generating energy in a way we don't understand, or our understanding of how planets evolve is incomplete. And that's where Artemis comes in. Not to look at the surface, but to listen to what lies beneath it. A new generation of seismic instruments will be placed across the moon, far beyond the limited regions explored before. They will detect vibrations from deep within, tracking how waves move through its interior, like a scan of a hidden world. For the first time, we may finally see what the moon is hiding at its core. And when we do, we may discover that the moon is not a relic of the past, but something far more unexpected, something still alive. What Artemis brings is something Apollo never could: access to new regions, repeated missions, and the beginning of a long-term presence on the moon. Not a visit, but a return. Because the moon is not just a destination, it's a record of how worlds form, how water arrives, how planets evolve, and sometimes refuse to die. We've been watching the moon for all of human history. We are closer than ever to understanding it, but the moon has surprised us before. Now, we're finally prepared to unlock its secrets, and when we do, we may end up learning just as much about ourselves. If you're curious about the interesting findings of NASA's Artemis II mission, be sure to check out the next video. Thank you for watching. If you found it informative, please give it a like, and don't forget to subscribe to the Cosmos Quest for more exciting revelations about lunar missions and the wonders of space. Until next time, keep looking up and stay curious.